Alright, here's a video on doubling and halving Vedic math way. It's video number W3. I'm doing these videos for a one-day workshop, and this is the video number 3 in that series. Let's continue. Play a game. Let's show you the significance of doubling and halving where we can use it. Okay, let's start here. Think of a number. Okay, you think of a number. Okay, let's continue. Double that number. You double that number. Let's continue. Add 4 to that number. Okay, add 4. Next step. Have it. Divide that by 2. Have it. Let's continue. Now you subtract the original number. The number you thought of in the first place, number step 1. You subtract that number from whatsoever you got in step 4. Okay, subtract original number. Wow, you got now 2. You should now have a 2. Okay, you have a 2 now. Anyone got something different? Okay, let's continue a slightly different game. Think of a number. Step 1, think of a number. Step 1, think of a number. Okay. Double that number twice. Now we are trying to multiply that by 4. Double that number twice. Okay, add 40 to that number. Add 40. Now have it twice, which is divided by 4. What's the number you got in step 3? In step 4, we are going to divide that by 4, which is have that number twice. Now, in step 5, subtract the original number. Subtract the original number. Okay, now you have 10. You got a 10 here. In the first problem, you got a 2, which was half of 4. In second problem, you got 10, which is half of the added number 40. Let us continue. We subtracted the original number in step 5. You had number in step 1, we subtracted then 5. You had number in 1, we subtracted then 5. The results you got 2 here and 10 here were the effect of the added number 4 here and added number 40 here. 4 divided by 2, we just halved it, is 2. 40 divided by 4 is a 10. Okay, let us continue. That left. Let's look up an example of division from the book Figuring. It's a book is Figuring the Joy of Numbers by Shakuntala Devi. The book has the following problem, which 360 divided by 7.5. Let's continue here. How would you solve it quickly and mentally? Is Vedic math mantra is short and sweet, one-line mental solution. We try to solve the problems mentally and quickly, one-line mental solution. Let's see, can you do that? Okay? We're studying doubling and halving. If you need some help, we would try to use doubling and halving here. Okay, let's continue here. What seems to be the problem here is that the numerator problem. Numerator looks pretty clean, 360. Denominator is not that bad, just a fraction. Is it numerator or denominator? Denominator is a little offending, so we would need to work on that. Okay? So would doubling help? Sure, that changes the fraction to a whole number. Okay? Let's continue here. What would you double? Would you double the numerator or the denominator? Numerator looks fine, so we probably double the denominator. Let us continue here. Go ahead and double. Okay, if you double that, 3 becomes 360 divided by 15. What is the problem now? Note that we do not change the problem. We only convert it to an equivalent problem. By changing that to 360 by 15, we have a different problem, not exactly the same problem we had before, and not even an equivalent problem. So we have just changed the characteristics of the problem. So here is the so far we have done so far. It's the equation, and the book doubles both the denominator and numerator twice to get an equivalent problem. So we were talking about doubling the denominator once by once, and the book actually doubles both the numerator 360 and the denominator by 4. Okay, doubles twice, multiplies by 4. Let's continue here. So that is like 360 times 5 divided by 7.5 times 4. Okay. And what's the equivalent problem now? Okay, now we have this one here, 360 times 4 numerator and 7.5 times 4 in the denominator. And we were trying to get rid of this fraction here, which I believe we got rid of. Okay, let us continue here. So the equivalent problem here, after by multiplying by 4 and dividing by 4, I have a 360 times 144 is 1440. If it, you can split the numbers 0 and 336, 36 one side, 0 on the other side. 36 times 4 is 144 and 0. Okay, and the denominator 7.5 doubled is 15 and doubled again is 30. 7.5 times 4 is 30, which is 7.5 doubled twice. Okay, so equivalent problem is 1440 divided by 30. Okay, can you solve it now? Okay, let's go ahead and solve it. What's the answer? If you cross out zeros here, then you had left with 144 divided by 3, which is 48. Okay, let's continue. So that answer is 48. The answer to the original problem is 360 divided by 7.5 is 48. Okay. Now we'll revisit this problem we studied before, 75 times 25. Okay. We did this problem in this video by completion, which was what we did is we converted 75 to its equivalent of 100 minus 25. In that section video, we were trying to use by completion. We completed 100 out of 75, and to get complete 100, we had to add 25 to 75, and to keep the problem equivalent, we subtracted 25. Okay, so 175 was 100 minus 25. Okay, let us continue here. Now we are studying doubling and halving. Okay, we in doing so, we did not change the integrity of the problem. We changed the problem to an equivalent problem, but we did not change the problem to a different problem. So we changed the original problem to an equivalent problem. Original problem had 75. We replaced that by 100 minus 25. Let us continue. Now, that's what we did before, which was by completion. We were completing 100. Now we are doing doubling and halving. Now we will work on the other multiplier, 25. How can we use doubling to change the problem to a simpler problem? Problem is a little harder here, 75 times 25, but we want to make it a simpler. Okay? Can we double 25? We're doing doubling. Sure, we can. Can we? Sure, can we double? Okay, let's see. So let's double it. They become 75 times 50. Okay, and that's not the same problem as we had started with. That's not even equivalent problem. Okay, is it 75 times 50? It is. Okay, but this is definitely simpler, but however it's not equivalent. It's twice as much as the original problem was. Let's continue revisiting here. So this what we have is it 75 times 50. That's definitely simpler, but however that's not equivalent. That's what we did in the previous slide. So equivalent problem is we had multiplied by 2, we have to divide by 2. 75 times 50 divided by 2. That is, okay, by multiplication and by division by 2. Double the numerator and double the denominator. Okay. In a whole number, denominator is 1 and we don't show it. Can you solve it now? It sure is easier to do than before. Okay, let's go ahead solve if you can. Okay, if you want to solve it, go ahead. Okay, how about double it that again? If you double that again, 50 becomes 100 and half become, by doubling the denominator, that becomes 4. So the answer problem becomes now we have 75 times 100 divided by 4. We multiply the numerator by 4 to get 100 here. We have to divide the denominator, multiply the denominator also by 4. Okay, now we use sutra by multiplication and by division by 4, and the mechanism, we use the mechanism of doubling and halvings. Okay, so we change this from 75 times 25 to 75 times 100. At least multiplication is easier here now, right? Straightforward. Okay, so now quick, what's the answer? Can we do that now? Are you ready? Solve this problem instead of that problem, and we have answer to this problem here. Okay, let's continue here. Here's the hint. It's the numerator is 7500 divided by 4, which is 1875. Okay, you do the math. You need some time to do the math? Go ahead, work it out. You can simplify some problems by doubling and halving. So that's what we are trying to do here. You can simplify some problems by doubling and halving. Let us continue. We use the number splitting. We usually use number splitting for doubling and halving problems. Okay, but you can look at other examples in the book. Okay, usual method doubling and halving is number splitting. Okay, which is, let's look at example 1 2 3 times 2. Okay, so we'll split then 2, 12 on one side, 3 on the other, times 2. Okay, so 12 we do it in two parts. 12 times 2 is 24. Left side 2 24. On right is 3 times 2. 3 times 2, so that's 6. That's a 246. Let's continue here. Take another example, 12 and 1/4 times 8. So we split that in 12 and a fourth. 12 and a fourth times 8. 12 times 8 is 96, and fourth, 8 times 8 is 8/4, which is 2. So that's equal to 96 plus 2, which is equal to 98. Let us continue here. Let's do halving now. If we have to divide 252 by 2, 252 by 4, okay, which is 252 is equal to 240 plus 12 divided by 4. We just split the number 252 into 2, which is 240 divided by 4 is 60, and 12 divided by 4 is 3. So 60 plus 3 is 63. So 252 divided by 4 is 63. Okay? Let's continue. We just did a divide and conquer. We divide 252 into two parts, sum of 240 plus 12. Okay, we just did it, divide and conquer. Divide into two different parts here. Okay? So let's do example 168 divided by 8. Okay? Here we split them like that, 16 and 8. We split the numbers here. So we divide in two parts. 16 divided by 8 is 2 on the left. 8 divided by 8 is 1 on the right. So which is equal to 2 and 1, which is 21. Let's continue here. So 168 divided by 8 is 21. 168 divided by 8 is 21, and 252 divided by 4 is 63. Let us continue. For more methods and example, please see Vedic Math Teacher's Manual, Elementary Level. You can get the book from vedicmaths.org. PDF form is free, and print form you can purchase. Okay? And you can also get a PDF form in Hindi also. The book figuring has some odd relations between 7 and the number 142857, repeating it like 142857, 142857, and etc. And she shows how do you get 142857, 142857 from 7. Let us see, and doubling. Okay, let's continue here. Let's see what she does. First line she has is 7 times 2 power 1. That's 7 times 2, which is 14. That is just doubling. So we are going to do doublings here, and we'll try to get in this 1, 4, 2, 8, 5, 7, etc. from these doublings. Okay. Let's continue double again, which is 7 times 2 to the power 4 2, which is twice as much as the first expression was. So 14 times 2 is 28, but we write these two digits to the right of 4. We have shifted 2 places to the right here. Okay. And every next step, we are going to shift the digits by 2 places to the right. Let's continue here. So, third power, we're going to double again. Double 28 is 56, but we will write down shifted, which is to the 5 is to the right of 8. Let's continue. So double again with the fourth power. It's 112. There are 3 digits here. One of them is aligned with the 6, and other 1, 2, next 2 digits are on the right of 6. Okay. Now double again to the power 5. What's double of 112? Anyone? It's a 224. If it split in half here, 11 on one side and 2 on the other side, double of 11 is 22, and double of 2 is 4. 2 to 4. 2 is aligned with this 2 here, and the 2 4 is to the right of 2. Okay, let's continue here. Next power, sixth power of 2, which is double of the previous one. So double of 2 to 4 is again by splitting is 22 4 4 8. 4 is aligned with the first 4, and 4 8 next 2 digits are to the right. Double again, 7 times 2 to the power 7, it's 896. 8 is aligned with 8, and 96 is to the right of 8. Eighth power of 2, which is double of the previous one, it is 1792. 896 is twice is, double is 1792. 1 and 7 are aligned with 96. 92 is to the right. Okay. And ninth power of 2 times 7, which is double of the previous one, doubling 1792, I get 3584. 3 is aligned with 9, 5 is aligned with 2, and 8 and a 4. Yes, continue. If we add these numbers on the right, we got say 1 4, right? 1 4, 2 8, 2 8, 5 6, and 1 5 7. Okay, then 1 or 2, 2 plus 2 is 4, that's 4 here. Okay, then this 2 and this 2 is 4 already. 2 times 4 is, and I'm trying to get 8 here. Okay, so some other carries from the next one here will get me 8. So given enough added terms here, if you keep adding terms, you'll keep getting those digits 142857, 142857. What we did here is we're looking for doubles here. 7 times 2 is a double first time, double second time with the second power, double again, and double again. 14 times 2 is 28, times 2 is 56, times 2 is 112. When I get 3 digits, we can see that I can number split here 224, 448, 896, 1792, 3584. The digits are aligned so that each next number is shifted to the right by 2 positions. Let's continue. So what's going on here? I know that we're doing doubling and adding, but we want to see what's the relationship between 7 and the other big number 142857. Okay, let's look at, first of all, 0.142857 is a reckoning number for 1 over 7. That means 1 over 7 is equal to 0.142857, and those 6 digits repeat after that forever. The total in the previous slide must be some kind of infinite series from the same. So whatsoever we were adding on the previous slide must be 1 over 7. It's some form which is the infinite series. Okay, let's see what that series might be. Note that 1 over 7 is equal to 7 times, multiply the numerator by 7 and multiply the denominator by 7. That's by, sutra is by multiplication and by division. So I got 7 divided by 49. Okay, so that's 7 times 1 over 49. That's how we would write down. 7 times, in parentheses, 1 over 49. So in the previous slide we had 7 times, and now we would try to figure out how can I get an infinite series from 1 over 49. Okay, let's see so that series is sum of 1 divided by 50 to the highest power, which is I is equal to 1, 2, 3. 7 times sum of this infinite series, which is of the type 1 divided by 50 to the power I. Okay? And for I is equal to 1, 2, 3, 4, and so on. Okay? Now quick, use your knowledge of doubling and halving to simplify the right side so that you can compare this right side with the right side of the previous slide. Can you now relate the RHS of this picture, this slide to the RHS of the previous slide? Okay, that's the question. So that's the homework for you guys, okay, and girls. That's all, folks. Okay, just remember, doubling and halving is another tool for simplifying some problem. So it's a tool. It's a special case of by multiplication and by division. In this case, we multiply and divide by a power of 2. So the factor used in multiplication and division by multiplication and division is this time is not any number like 3, it's a power of 2. Okay, let's go look. Are you can use Vedic math teacher's manual elementary level. You can purchase that in the print form or get PDF form for free from the vedicmaths.org, and Hindi edition is also available in a PDF form. Figuring the Joy of Numbers is a book by Shakuntala Devi. Okay, and that is it for this video.